Customers connected under medium and high voltages are generally concerned by the billing of reactive energy by electricity suppliers. This can significantly increase a bill for a water utility. It is therefore important for major consumers to implement suitable offsetting measures for reactive energy, and this in order to both reduce their electricity bill and stabilize the quality of the current supplying power to the equipment. First, we will discuss why it is of interest to implement reactive energy offsetting measures. Then, we will look at the different layouts available to implement these offsetting measures. Electrical power may be divided into three parts: the active part, P, in watts, the reactive part, Q, in reactive volt-amps, and the apparent part, in volt-amps. The greater the reactive power required by a facility for a fixed active power value, the higher the current delivered to the site needs to be for it to operate. This generates several constraints for electricity suppliers and significant extra costs for customers. This reactive energy may, however, be offset by implementing suitable measures that aim to improve the power factor, also called cosine phi, in order to bring the value as close to 1 as possible and reduce the total amount of energy supplied by the electricity grid. Offsetting reactive energy must be carried out as near as possible to the sources of water, i.e. tube wells, pumping stations, and water treatment plants. To do this, we use capacitors, generally fitted in series, that supply a part of the reactive energy required by pumping facilities instead of the electricity grid. Offsetting may be implemented in three different ways in terms of the location: individually, locally, or by sector, and globally. In the case of individual offsetting, a series of capacitors is directly connected to the motor's terminals. This offsetting technique is ideal because it produces reactive energy at the same location where it is consumed, and in a quantity that is adjusted according to demand. In the case of local, or bi-sector offsetting, a series of capacitors is installed at the beginning of the facility's sector to be offset. This is suitable when the facility is big and includes various sectors whose loading modes are different. This is particularly the case of a treatment plant with its different treatment processes that have their own electromechanical assets, such as pumps, actuators, agitators, and aerators. In this case of global offsetting, the series of capacitors is connected at the beginning of the facility and offsets all the electromechanical assets. Offsetting value may be fixed or in levels. In the case of a fixed offsetting value, the entire series is operated on an on or off basis. Commissioning may be manual, via a circuit breaker or switch, semi-automatic, using a contactor, or automatic, via servo control of the motor. This type of offset measure is used when the reactive power is weak, i.e. less than 15% of the transformer's power, and when the load is relatively stable. In the case of offset levels, the capacitor series is split into levels, with the possibility of starting up more levels or fewer levels, generally automatically. This type of series is installed at the head of an electricity distribution facility. It allows for step-by-step regulation of reactive energy. The switching on and off of levels is managed by a varmetric relay switch. What you need to remember. We have seen that it is possible to act on the quantity of reactive energy consumed by the facility by increasing the value of the power factor, cosine phi, which enables the pumping site's electricity bill to be reduced. This is possible thanks to the offsetting measures based on the series of capacitors that can be installed in various locations at the facility according to needs, and enables fixed or level offsetting of the reactive energy consumed.